Alright, so this is lesson number 50, absolute value functions. We are learning how to graph absolute value functions with this lesson. Okay, so we'll start off by just completing a table. So anytime you're going to graph a function, it's always a good idea to start with a table. So if we plug in -3 over here, what's the absolute value of -3? It's just going to be +3. We can continue with that, so -2, absolute value of -2 is 2, absolute value of -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, and the absolute value of 2 is 2. So then we can go ahead and plot these points. -3, 3 is going to be right here, -2, 2, -1, 1, 0, 0, 1, 1, and then 2, 2. So if we connect these these points, I should probably use the solid, there we go. So if we connect the points, you'll see we end up with this graph that looks like a V. Okay, so this is our basic absolute value graph. Let's go on to another example. Alright, sorry about that. Here are our steps, so if you're in the video, go ahead and pause and write these down. First, what we want to do is arrange it into this correct form. The y equals a times absolute value of x minus b plus c. And again, remember that these are our absolute value bars. Okay, so second is you want to graph the vertex at b comma c. The vertex just means the point of the V. Okay, so this part right here. Then you're going to use A as the slope for the right-hand side. So this A value right here is what you want to use as the slope for the right-hand side. Then you're going to use the opposite of that as the slope for the left-hand side. This note down here is just saying that if your A value is negative, your V is going to end up looking upside down. So let's see how this works. Again, we can always start by making a table. So if I plug in, say, -5 for x, -5 plus 3 is a -2, and the absolute value of -2 is just 2. If I plug in -4, -4 plus 3 is a -1, and the absolute value of -1 is 1. -3 will give me -3 plus 3 is 0. -2, I get a +1, the absolute value of 1 is 1. And then -1, I'll get +2. So I can plot these points. -5, 2 is here, -4, 1. -3, 0, -2, 1, and -1, 2. Okay, so I get another V graph. This is just shifted a little bit. Okay, now if we do this using the steps instead, we should rewrite it into the correct form. So our A here, there's not a number in front exactly, but there's always that 1, right? So our A here is 1 times absolute value of x, and then this is a plus. And if you remember back, our standard form for these absolute value functions needs to be a minus there. So we can make this a minus if we then change the 3 to a -3. So x, the absolute value of x minus a -3 means exactly the same thing as the absolute value of x plus 3. Then for our C term, we don't have anything on the outside, right? So we can just have +0. That tells us that our slope for the right-hand side, or our A term, is just 1, and our vertex is at -3, 0. Okay, so if we chose not to create a table, we could have graphed using these facts. So the vertex is at -3, 0. That's exactly where we put ours as well. Then the slope of the right-hand side is 1, so we would go up 1 over 1. And the slope of the left-hand side, the opposite of a, would be -1. So that's how we would get the left-hand side. Okay, so let's try a more difficult example. Here you'll notice that there's a number in front of the x. So that presents just a little bit of a problem because our standard form, it just has a 1 in front. So we need to get that factored out. We can rewrite this as 2 times x plus 2, right? Factoring the 2 out of this 2 and the 4. And if you remember from our last lesson, we have the property that if two things are being multiplied within an absolute value, we can separate them. So we have the absolute value of 2 times the absolute value of x plus 2. But the absolute value of 2 is just 2. And then to get this into our standard form, remember we want a minus here. So instead we'll make this x minus a -2. And again, there's nothing outside of the absolute value, so we'll just have plus 0 for our c term. This tells us that the vertex is at -2, 0. And the a term is 2, so the slope of the right-hand side of our v is going to be 2. On our graph, then we can plot this vertex point at -2, 0. It's right here. And the slope of the right-hand side is 2, so I'll go up 2 over 1 to plot my next point. And that's the right-hand side. For the left-hand side, I'm just going to take the opposite slope, so I'll go up 2 and then to the left 1. Okay, let's just do a couple more examples. This one is a good one to practice on your own because the a, b, and c terms are already nicely there for you, so I suggest practicing that on your own. Let's look at this one. So here I have a negative in front of my absolute value, so that tells me the a term is going to be a -1. Let's rewrite this whole function though. So we have y equals negative times the absolute value, and then instead of plus 1, remember we want this to be x minus a -1. And this has a minus sign here as well, but in our form that we want, this should look like plus c. So I can make it look like that by having plus and then -2 in parentheses. And remember, this negative is just like a -1 out here. Okay, so our a term is -1. Our vertex is -1, -2. And this tells us the slope of the right-hand side is going to be -1, and then the slope of the left-hand side will be a +1. So let's plot the vertex at -1, -2. Then the slope of -1 for the right-hand side means we're going to go down 1 and over 1. And the opposite of that for the left-hand side will go down 1 and to the left. So this addresses that note from earlier where since a is negative, the v is flipped upside down. Okay, so there's a few more examples for you. I'll just click through them so that you can pause the video. But we're going to stop here for today. So that's all for today's lesson.